we look about the bright details we want to keep them, like here. I do several iterations, lowering the radius. And I watch the picture carefully. Can you see? So the background stays sharp and not too many details from the bright dots here is destroyed. And now the stars start to get smaller and smaller. Radius, let's put 11. You can see the stars are almost gone.
Όταν με την εφαρμογή του mapping προσπαθεί να εξαφανίσει τα άστρα τα οποία είχαν το χρωματικό πρόβλημα, όπως είδαμε στην αρχή, στην πρώτη εικόνα, χρησιμοποιώντας το εργαλείο Dust and Scratches και όπως βλέπετε εξαφανίζει τα άστρα που είχαν χρωματική απόκληση.
And smaller and smaller radius.
Και αυτό το κάνει με επαναλαμβανόμενες εφαρμογές του εργαλείου Dust and Scratches με όλες μειούμενες.
Typically I use maybe 7 iterations. Okay, now it's good enough. And you can see there's a lot of dark details gone. If we compare this to original, place it here. You can see it's not only you are losing dark details, but you can return them back, and you should put them back by changing the mode here darken. It means that it puts back only the dark parts of the image, so not stars. If I select the mode lighten, the stars will be there. Similar filters can be found in many softwares. Okay, the idea is to get rid of the stars, and if there's some remains of the other stars, I can destroy them too. I flatten this, and I use one more time the noise filtering, doesn't scratch, and select a really big radius, maybe 69. And look at this. I go down, it starts to disappear. Now it's gone. But all the picture is pretty much gone. But I use the layer mask, hide all, and then I use the white pen to paint them visible. It's quite fast. Okay, it's good enough. And when you look levels, now it's very bright. Oh, it's a mask, sorry. Merge. Look at the levels now. There is plenty of empty room here. This is just a nebula. It's very bright here, we can use curves to take its part of it down. Okay, so far so good. And we do the same thing to S2 and O3. And this goes interesting because there's so little signal. I can use a much stronger noise reduction here. You can see the stars are almost gone. There's very little details. Okay, it's almost clean. And then you can use a tool for removing those stars there. It's still visible. You can use copy or whatever you like. And then I stretch this picture because there's no stars to blow up. You can see there's a lot of signal, very much noise, but we don't have to care about this noise because this is only for the color. We can smooth it out with no problems. We use blur, and we can use the radius because there's very little details here, as you can see. Something like this. And the background is still uneven. We can use against, we can clean this up very easily. We can use medium filter with some higher radius, like this, and then just normal curves. This should be quite very dark, and we put up a little bit. As you can see, the original picture doesn't even show this. Doesn't even show this area here. This is real data. It's just above the noise level of the background level. Okay, we keep it here. It looks awful, but don't worry. Let's do the same with all three.
JP θα δείξει και σε normal ρυθμούς, οπότε...
Or you can do it with the noise filter as well. Like this. And I return again the dark details. Down. Some more gleaming. Usually I do this, it doesn't take too long time. I do it quite well, but it doesn't have to be perfect. You will see. And now I can stretch this too. And you can see there is a lot of signal here. Much more than you thought. The original picture looks like this. And now I smooth it blurring and use some medium filter too. Okay, now we have three channels. I call them Tonemap channels. Okay, and now we do the trick and combine those color channels. RGB. And then I use, this is called 3. I copy it and I just pass it blue channel. This, and then I pick up the S2, copy it and paste it as a red channel. And now we have picture here, and now just a little adjustment with the curves. I back off the green, okay, a little bit. And turn off the red. Couple of times. Raise the blue a bit. Green again. It is a traditional work with curves. Okay, don't spend more time here. So here is now the color It's only for color. And here is the original picture which was spreadsheet, the same method, with stars. Okay, how we put the stars back? Let's go to the first picture. Yeah. Where's the instrument? Okay. Here we have the starless H alpha image, and here we have it with stars. This is the crucial point, actually. This is, I call it a separation map, because we remove something, we have to put it back. This is the original picture, this is a starless picture with no stretching, no level change. I use apply image and subtract. So what you do, you like minus the starless image from the image of the stars. So only thing left is the change. And this happens. Second. It's a copy. Add to image. And subtract. With this image, there is only stars and some other details we accidentally remove. And if I take this and put it back to this image, it's only a color map. There's no luminance here. And use the linear add. So we have stars here. And everything else we remove. But I won't do it yet, because this is blur, not sharp image. We have the starless channel here. It's alpha. We process this as a luminance. It's very tempting to use H alpha, which has the most details, as a luminance channel in narrowband image, but you actually can't do that, because it doesn't contain any information from O2 or O3 and O2 and S3. Opposite. O3 and S2. It doesn't contain any information. And if there is area with O3, strong emission, and you put H alpha luminance, you dump down it. It doesn't look nice. There is no luminance information. So what we do now, we process this starless image to look as good as it is. Very easy to process because you don't have to care about the stars. It's very burned, but now it's very traditional curves. You bring down the two bright parts and take up the parts which are too dark. You can have good details here. With more contrast and background. Okay, this is H alpha, tone map with H alpha with no stars. But we need the information from O3 and S2. We put it here. We use these. This is S2 and this is O3. I put starless O3 top of the starless H alpha and change the monitor screen. Similar filters can be found in many softwares. It looks quite bad, but then I lower the percentage. And actually, if you are very pedant, you can use the real percentage, what is in the nebula. How many percent of the brightness is from S2 if you have the information. But I use just a visual basis. So I added about, not much, 11% maybe, 10%. Maybe less, 9%. Let's use 10. And you can see, if I blink, it's not the same picture. There's information. And I do the same with S2. That was O3. And turn my screen and lower it to something like 10%, 9%. And now I can flatten this image. So this is O3 S2 boosted H alpha. So now you can use this as a base for the image, and we have stars here. We put the stars back, and when we use linear mode, it means it's just linear additive. There is no algorithm between. So it adds back everything byte by byte. So there's no information will be lost. And now you can see here's a picture. And what is the nice part? We have all the data in different signal level data in the different levels. So the stars are here and the nebula are here. We can continue to work. We can reduce stars. We can use curves. If this star is too bright, I use curve and bring it down. You can see. I can control the stars precisely I like without touching the nebula, and vice versa. I can control the nebula without touching the stars. So by this way I can change the look and feel of the picture, how much stars are dominating. They all are there. I just decide, I am the person who decides what is look, because this is my picture. It's not a fake, it's not image manipulation, it's balancing the picture. You can do it by photographing. But with astrophotographing, it's extremely difficult. You need to play with the exposure times, which can be days. But now you have a goal, and you can control everything, which I like. I'm a control freak regarding astrophotos. And of course, you can add some sharpening or noise reduction if you want. I don't use noise reduction because it's, let's say, it makes plastic look to the images very easy. But if you look very close this picture, you can see there is not only stars, but there is white noise. What we did when we separated stars, we also separated dark noise and white noise. White noise is there where are stars, and the black noise are in the starless nebula. Now we can control this noise very delicate way, because it's an electric noise, it's 1 pixel size. If we use a little bit filter, which is any software should have it or will have it, it's a minimum or maximum. We use minimum filter, and its minimum radius is 1. Okay, stars are gone, but then I use practically transparency. Here are all the stars, now they're 1 pixel minimum. I use very small percentage, something like 16. The white noise is gone. It's noise free, there's no white noise in this picture. If I go one step back, you can see, you compare yourself. History here. Curves. I did a very close picture. You can see this is white noise here. Now it's gone, almost gone. I never remove it totally because it makes a fake feel and look and feel. Okay, here we have a picture, and now we can balance the actual nebula by using curves. It's too bright. Okay, let's keep it this way. I flatten this. You can do it endlessly, you can overwork easily. And now we have color and we have now the luminance. Now we put it here. And turn it to luminance. It's too bright, I turn it down. And we can control it endlessly, but you see the idea. It's a smooth picture with no noise, no purple halos, and then you can balance the colors the way you like. Sometimes I use selective color if there's authoritative information. So that means only that some greens. I add some more beautiful, like this. So it starts to to be, it's not perfect, it's not ready, but it's relatively noise-free, a lot of details. For example, here, this shouldn't be green. I balance the levels, I use this a lot. I mark the place which should be neutral. This is the same tool you can find in Pixel site and everywhere. And here. This is sample of the very fast sample of the tone mapping. The basic idea, what you should think when you use some other software is you separate high and low signal noise components and give us separate processing. And what was the most important, I removed this, the difference map. I saw it again because it's so important with a different picture. I have several samples here, but now I'm using my latest picture. It's just the H alpha, we don't now do colors. But this is 5-hour exposure of one object in Cygnus, which I can show you, which gives you some idea what is it. You can find it here. Okay. This is the area here. It's complex looking filaments. This actual picture was like this area, 1 square degree. It's here. This is stretched. There's nothing. It's just some weird shapes and stars. It's not really much information. I duplicate this picture. I usually make another layer for this, and then I use the noise reduction, dust and scratches. I select the place where is some higher signal, so I don't harm it. And again, several iterations. Can you see the picture in there? Because I can't select, I can't see it from here, so is it clear, the picture in the screen?
Yes.
Okay, this is good. Now, there's still some stars here, you can see, but as the last time I used a bigger radius for them. Like this. And because it destroys about everything, I use a layer mask to hide it, and only the needed points I'm using underlying picture. This is very fast for removing brighter stars. If you have done telemapping, this is very useful. You not spend the whole day. What I usually do, if I'm not sure if something is star or not, I don't want to remove the real, I bleed with the picture with stars. So like here, this is not a star, this point here. It's a part of the nebula. I try to be as precise, but you don't have to be too precise because you will put everything back at the end. It doesn't matter if you accidentally remove something which is, you accidentally remove something which is part of the picture because they will be back. So. Just the brighter ones. This isn't anymore so precise than it used to be because of the uses of the different stars. And before we do any stretching or other stuff, we create the difference map, because they have to be the same picture, only the difference with removing the stars. I use the apply function and subtract. It can be found anywhere. Different names, but same principle. Like this. And now this image, it contains all the stars and even all the noise I removed by accident. And this is the picture with only the nebula. And now, when we stretch this, you can see how powerful this is, really. There's so much empty space I usually leave something here. I don't take everything out. But you can see how much information there really is. The picture we started with has practically nothing. We can pick it out. And I use shadow and highlight sometimes to if there's a very big contrast. I want to open up the dark nebulas a bit. So I use there's some. I don't know why they use this backlit. Okay, I'll open it a little bit, I back it off. This Photoshop has a settings, and this is not my Photoshop. There's a different pre-settings, so I use different tools opening up the background. Okay, that's good enough. As long as it looks nice. Why I select this target, it looks like a big lasso. It's quite interesting. After I shoot, all three and S2. What's happening? I reduced the picture a bit. Processing this. Okay, thank you. Okay, I just put the stars back, and you can see it gives me so much room to work with. It's the original problem, but again, don't think so much how I did it, but think about why I did it. There's always 1,000 different ways to have the same result. And whatever suits you best, whatever software you use, you can find your own way. But the basic idea is that you don't try to control and stretch all the image components at the same time. And the difference map, I got the name, I have given that name, it's not a common term, the difference map. It maps the difference between two images. It's like removing one image to another. It's a basic function in all image processing tools. By that way, you don't lose any data. Even it looks very harsh when I remove the stars and work like a lumberjack in in a lady's underwear shop. But the result is that everything is going to put back. There is no data loss, there is no artifacts. Everything is in the picture, which is coming out there. And then you can control, because the starting point was this. And this is a heavily stretched picture. There is almost nothing. And you can see it's a lot of signal there. I think it will be a beautiful picture when it's ready. I'm going to make a 2-panel mosaic out of this. Okay, let's take another sample. How we can use those stars, because we have stars in a separate, we can use this as a mask, of course. I saw an example with that with the LGP image, with the normal broadband picture. This is also tone mapping. It doesn't have to be a narrowband image. I use this one as a sample. This is LDN1250, the dark nebula. This is color information, this is luminance, and this is the ready-made picture that I put away for a moment. The problem with this is, you can see this is along the 17-hour exposure. There is very bright stars, and because it's a dark nebula, there is no, it's all the reflection stuff, and it's dark, there is no colors really. A lot of stars, because it's in the galaxy plane. It's nightmare to process. You blow up the stars if you try to pick up the very faint information here. And this is already stretched, unlinearly stretched in CCD stack software. It looks like a nightmare to try to process in a dark nebula like this. But I do it very quickly. I will do the same tone mapping processing to this. Actually, it's a little bit easier because there's less details. You can be more strong with the star removing things. It looks awful when I do this. I destroy the image basically. I use another iteration with quite much more radius. Too long. Okay, it's good. And now I return the dark details because with darken function. So now all the dark details I put them back already. And I flag this. So here is image and here is it without the stars. And now I build a difference map again. Think about what I do, not how I do, because you will find the tools in your own software to do the same thing. The name, I forgot what is the name of the picture. Here. Now all the stars are here, and actually everything else removed. And now we can use the traditional tools, curves and levels. It's nothing else, but we have much more to play with. Okay, it looks like this now. I test it, I bring the stars back temporarily to see what's happened. Oh, it looks much better now. If you compare where we start, without hundreds of curves and stuff. And there is with the brighter stars there is can be some halos, but we take care of them in a second. But all the details are there. I did it very, very fast, but you got the idea. Stretching, curves, levels, and put stars back. You remain the stars as beautiful as they were in unstretched pictures. It's what always happened to you. Well, we have beautiful stars after you work a while. The stars are like footballs with a white center. And I mentioned about using this information as a mask. So, for example, if I want to, now the stars are in a different level, except they are not because I flat. Yeah. Now they are different level. I can control the bright stars, for example, here, quite freely, as long as I keep the background same. So you can see what I can do. There is no limits. Keep stars. It's a matter of taste how you want them to be, but something like this. And the difference from the previous is, you can see it here. They go smaller. All the, so it's, and now the stars are very much dominating the picture. You can do some star reduction, but I try to avoid the minimum filter or something, this crunch the stars and make them square. I rather use curves. So if I want to dim down the bright stars and bring out the dim stars, I use the S-curve, like this. So I bring up the very dim stars, and if you look at the result, you see what happens here. Or if I want to change the general function, the look and feel, I dim down all the stars. So it's just a matter of taste. But remember, it's very easy to overdo. So, like this. You see the difference. And this is RGB image. It looks quite pleasant. And because we have a starless image here, many times I use this technique wrong. I copy the starless layers, do it at top of everything. I smooth it up a little bit. I don't want to add noise, maybe radius. It depends in image scale, but something like. Usually I use the same radius as the star, half width full maximum. So in this case, it's something like 2.6. So I don't lose the details because that's the limit which under you don't have any details. And then I use high pass filtering, which is a very common filter. It can be found basically in every software. And depending what I want to bring out, I set the radius first, usually very big, let's say 80, 60. And then I use the mode, it's called soft light here. You can see the effect. And this is possible because I use starless images. The stars will blow up like firecrackers. But now you can see I bring up a different kind of elements from the image, the dark, and it gives a local contrast. I call it local context. And what I usually do after this, I don't add it like that. I make a copy of the original picture. I have no idea. How much time I have no idea. Sorry? 2-3 minutes. Okay, we have only solid time, so I will show you the car's star color. This is most important. Is okay? So you got the idea. I have the RGB here somewhere. No, this is not. Oh, here. We use this as a color. And you see, I put use it as the color chamber. Like this. And because we have stars in a separate level, we use this as a mask. I flag this up. I flag the whole image. You can do this trick to our old picture as well. So this is the luminance plus color, and here are only the stars. So I want to, star colors are not good. They are almost non-existing. I move this picture here, turn to mode color, and flag the whole image. Now what's happened? We have here only stars and only color. To see better what we have here, I large the star, which sounds ridiculous to do as photo. I want to as big stars as possible. I use maximum filter, and maybe radius, something I can see properly, 4, 3. And very faint colors, I use brightness, hue and saturation, I bring up saturation. There is a star, there's bluish colors and there is too much red. But actually there is nice colors behind all this. So I use a little more saturation and then I change the curves a little bit less red. Like this, and what I did, then I squeezed, because I enlarged the stars to see them, see the color. Then I squeezed them back small by using radius 2, and then turn it on color. Now you see there is color in the stars. And plug this image, and if this is starless picture, I just plug it back linearly, but now there's already stars, so I select the stars here by using threshold. Like this. Select color range. Here. Selection. And I move the stars to an original image here and turn the mode color, and what happened. There is a quite strong, beautiful star color. I can add more like this without blowing the stars. So this is storm mapping. Thank you.